Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Camellia by Sotir, and here are the rules. Sudoku. Normal Sudoku rules apply, which means place the digits 1 through 9 once in every row, column, and 3x3 box. German whisper line. Starting cells, row 1, column 2, row 1, column 8, row 7, column 2, row 7, column 8. Digits along a green line differ by at least 5. So for example, if this were a 3, this would have to be an 8 or a 9 to make sure that there's a difference of at least 5 between those adjacent cells on the German whisper line. Red band line. Starting cells, row 2, column 5, row 3, column 3, row 3, column 5, and row 5, column 6. And this pattern, it makes a nice little camellia-like floral pattern. Digits along a magenta line contain a set of consecutive digits in any order without repeats. So, for example, if you had a 1 along one of these lines, say there was a 1 here or whatever, you would have to have, this is 1, 2, 3, 4, 5, 6, 7 in length. So it would have to have the digits 2 through 7 in addition to the 1, right? Because the only set of consecutive digits that one can fulfill with 7 digits is 1 through 7, right? If you try to add an 8, you would inevitably have to have a gap in between, which was not consecutive. So that would not fulfill the Renban line then if that were the case. And that's how Renban lines work. Black crop key. Digits separated by a black dot have a ratio of 1 to 2. So for example, if this were a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. White crop key. Digits separated by a white dot are consecutive. So for example, if this were a 6, this would have to be a 5 or a 7 to be consecutive with that. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. First things that I see. What you have is, you have 2 cells here, which have to be the same set. So on a German whisper line, you'll always alternate between low digits, which is 1 through 4, and high digits, which is 6 through 9. Because the lowest digit, 1, can only be next to a digit that is 5 away from it, which would be 6 and above. So therefore, 1 through 4 always must be next to 6 through 9. And if you have a 6 through 9 digit, the highest digit, which is 9, always has to be next to a 4 or below, which is 5 away from it. So therefore, you'll always alternate between sets. So this is either low or high in the set situation. Now the thing is, even if this is low and high, they both have to be between 2 unique digits. So it can only be 1, 2, 3 or 7, 8, 9 along there, because 4 and 6 specifically have to be adjacent to only 1 unique digit on a German whisper line, and that's 9 for 4 or 1 for 6, right? So we know if we try to make all of these the same set, it would not work, because one of them would have to be 4, and that would be adjacent to, or 6, and that would have to be adjacent to 2 unique digits on a German whisper line, which it can't be. So therefore, these have to be opposite sets. So we're going to make, and that's the case for all of them, right? So we're going to make this randomly pink. I guess let's make this randomly yellow, actually, and this randomly orange. So therefore, these cannot be yellow because, again, you would have to have 4 from the same set, and then one of them would have to be 4 or 6, which would have to be only with one unique digit, but they all have 2 unique digits. Therefore, these both have to be orange, which forces these to be yellow, which forces these to be these have to be orange, and therefore these have to be yellow, which forces these to be orange, and therefore this has to be yellow. Well, this is interesting here, right? If this is low, say this was low, the problem with that is if it's low, it has to be 1, 2, or 3. Obviously, it couldn't be 1 because it's uniquely between 2 distinct digits. And we know this has to be 1, 2, 3, 4, or 6, or 8. So if this is where we're 1, 2, it cannot be 4 because it's next to 2 unique digits on a German whisper line. Therefore, if it's low, it has to be 1, 2, or 3. And if it's 1, it can't be 1 because that has to be consecutive with two unique digits, which 1 is not. If it's 2, this would have to be 1 and 3, and this would have to also be 1 or 3. Actually, I'm thinking about it. It actually can't, yeah. This can't be high, thinking about it. If it's high, it can't be 6 because that would be between two unique digits. So therefore, this would have to be 8, which would force the consecutive digits it's with to be 7 and 9. But then that leaves one other digit that could be high in the box, which would mean this would have to be 6. But then that's between two unique digits on a German whispered line. So this cannot be the case. Orange cannot be high. It has to be low, which means yellow has to be high. Well, we tried one. One doesn't work because it can't be between two unique digits consecutively. Can't be consecutive with two unique digits. And it can't be 2 because if this is 2, this becomes 1, 3, and this would have to be 4 as the lone remaining unique digit on, but it would be next to 2 unique digits on a German whispered line, which is not allowed. So this can't be 2 either. Therefore, this must be 3, which means it must be next to 2 and 4, which means the lone remaining low digit has to be a 1. Therefore, these are all lows. This 3 has to be in a 1 to 2 ratio with 6, so therefore this is 6. Therefore, 3 can only be next to an 8 and a 9 on a German whisper line. So therefore this is 8 and 9, and this is also high. So therefore the remaining digits are 5 and 7 in box 3. Well, what can this digit be? It has to be either 2, 4, or 8, because those are the only digits remaining that can be next to a black Kropke dot, right? Because 5, 7, and 9 cannot be, because 5 is not double anything. Neither is 7 or 9 because they're odd. And if you double any of them, they become a non-digit as 10, 12, or 14. Sorry, 10, 14, or 18. So this has to be 2, 4, 8. If this is 2, this could be, if it's 8, it cannot be 4, so this can't be 8 specifically. If this is 2, it could be 1. If this is 4, it has to be 2. So either way, one of these has to be a 2. This is consecutive with that. This 1 has to be consecutive with a 2. So this is also low, which means this is a low and it's a 4, which means it's in a 1 to 2 ratio with a 2. This has to be 1 or 3. This is 7, 8, or 9. This is 7, 8, or 9. So this cannot be a 6. It cannot be 5. Therefore, this is also 7, 8, or 9 to be consecutive with. Therefore, what's the last digit? It must be a 5. So this is a 5. This is a 2. Anytime you have 3 cells separated by 2 crop key dots, it has to be either 1, 2, 4 or 2, 4, 8, because you always have to have continuous multiplication of 2. So if it's 1, you multiply by 2, that would give you 2, and then multiply by another 2, which would give you 4. Or it could be 2 multiplied by 2, which would be 4, and then multiplied by another 2, which would give you 8. So either way, this has to be either 1, 2, 4, or 1, 2, 4, or it's 2, 2, 4, 8, or this is 2, 4, and 8. So either way, the 2 and the 4 both have to be here in one of these 3 cells. This can no longer then be 1 or 2, cannot be 2 or 3, can't be 3 or 4 or 5 because of this 5. Can't be 5 or 6, so this has to be at least 6, 7, 7, 8, or 8, 9. We're not sure which, because these are consecutive. This, therefore, is a high. This is in a 1 to 2 ratio, so it cannot be 4 again. It could be 1, 2, or 3, but if this were 3, it would have to be with 6, and that's not allowed because of that 6. Therefore, this is only 1 or 2. 1 or 2 can be in a ratio. 1 can be with a ratio with 2. 2 can be with 1 or 4. We're not sure. Either way, this has to be a low. So this is 3 lows. We know one of these has to be a 5. And one of them has to also be a 7. So we know there's a 5 or a 7 here, and it's with another low. Because the 7 is a high, so this has to be 1, 2, 3. It cannot be 4. This has to be 2, so it's either 1, 2 or 2, 4. So therefore the 2 cannot be in the rest of the row. So this is 1, 3. Again, this can't be 6, so it has to be 7, 8, or 9, 7, 8, or 9. And this can't be 7 specifically. So this is, because of the 5, 7 pair in row 3, this can't be 7. So 8 or 9 can be only consecutive with 7, 8, or 9. Therefore, we have a 7, 8, 9 triplet in column 2, which eliminates 7, 8, and 9 from the rest of the column. Therefore, this must be 6, and that must be consecutive with 7. So this can no longer be 7 because of the 7 in the box. We now have the 8, 9, 8, 9 pair in column 2, which eliminates 8 and 9 from the rest of the column, so therefore this must be a 7. This 7 can only be next to a 2 and a 1 in a German whisper line, so this must be 2, this must be 1. And this 2 has to be in a 1 to 2 ratio with something, so it must be with 4. So 1 and 4 can no longer be in that row. 4 can only be consecutive with 5, so if this were a 5, it would have to have a 4 here, which is not possible. So this cannot be 5, it has to be another low. So therefore, where is the 5 in column 2? It must be here. So these are 1, 2, and 3. This is 1, 2, or 3. If this is 2, this would have to be 1 and 3 next to it. And 1 can never be next in between 2 consecutive digits. So if this were 2, this would have to be 1 and 3, but that would eliminate all possibilities for this cell. So this has to be then 3, which is next to 2 and 4. We now have a 2, 3, 4, a 2, 4 pair in box 7, which eliminates 2, 3, and 4 from the rest of the box. So therefore, this can't be 3, this has to be 1, and that has to be 2 then. The remaining 2 digits are high in box 7. Okay. This 7 means that there cannot be another 7 on this Ren band. So this can't be 7, which forces this to be 5, which makes that a 7. Now this 5 and 7 means there cannot be another 5 or 7 on this Ren band. So this can't be 5 or 7, which forces this to be 3, which means this can't be 3 and this can't be 3. Let's see. The 3 can only be next to 8 and 9 on the German whisper line. So this is 8, 9, 8, 9 pair, which leaves 6 and 7 left in box 7. So this can't be 7. This has to be 6, which makes that a 7. 5 can no longer be here, so 5 is one of these two. 3 has to be one of these remaining two cells. This Renban line requires a 7 because it's 7 length. So it's either 1 through 7, 2 through 8, or 3 through 9. So where could the 7 be? It can't be any of these cells, so one of these 3 is a 7, and this can't be a 7. Therefore, this is a 7 here. Similarly, one of these cells has to have a 7 on it also. Well, this can't be 7, again, because it's 1 through 7, 2 through 8, or 3 through 9. Well, this can't be 7 because of this 7. These can't be 7 because one of these has to be 7. This can't be a 7 because of that 7. So one of these two has to be a 7. Well, similarly, this also requires a 7. And these can't be 7 because of this 7. These two can't be 7 because there's a 7 here. And this can't be 7 because one of these two has to be a 7. Therefore, the only remaining possibility for 7 on this line is here. So this is a 7. This can no longer be 7. This has to have an 8. It's either 7, 8, or it's 8, 9. So this can't be 8. This is 7 or 9. 7's only consecutive with 6 or 8, so this is 6 or 8. 3 is only consecutive with 2 or 4, so this has to be 2 or 4. We do now have a 2, 4, 2, 4 pair in column 5. That means the rest of the column cannot contain 2 or 4. This can't be 7 anymore, so this must be the 7, which means this can't be 7, so this has to be the 7. Okay. The remaining cells in column 5 have to be 1, 5, 6, 8, and 9. So this is 1, 5, 6, 8, 9, 1, 5, 6, 8, 9. These have to be 1, 5, 6, 8, 9. But this can't be 1 or 6. This can't be 5 because of the 5, 7 pair in the box. Okay. This can't be 7. So now we have an 8, 9 pair in column 8, which eliminates 8 and 9 from the rest of the column, which means this has to be 7. And 7 can only be next to a 1 and a 2 on a German whisper lines, therefore this has to be 1. This can't be 2, so this must be a 4, which makes this a 2. The remaining digits now are 3 and 6 in row 8, which means we have a 3, 6 pair in box 8, which eliminates 3 and 6 from the rest of the box. Therefore, this must be an 8, which means this can't be 8, this can't be 8, this can't be 8, and this can't be 8. Okay. Let's see. 4 has to be one of these two cells. 4 is one of these cells. It could be 5 or 9, and it has to have a 2. Oh, wait, hold up. Where are 2 and 4 in row 7? It can't be any of these cells because we have a 2, 4 in that box already. Can't be any of these cells because they're filled. Can't be this cell because we already have a 2, 4, 2, 4 pair in column 5. Therefore, this must be 2 and 4 exactly. So we already have a 2 and 4 here. Therefore, on this Renban, you cannot have another 2 and 4 along it. So this cannot be 2 and 4. So this is not 2 and 4. We know this is either 1, 2, and therefore this is a 4. So if this is 1, this is 2, this has to be 4. If this is if this is an 8, this has to be 4, which makes this a 2. So we have a 2, 4, 2, 4 pair now in these cells. This is 1 or 8 with it. What are the remaining digits that have to be on this Ren band? Well, we're still missing a 3 and a 5. 5 cannot be here, therefore this must be 5. And therefore this must be a 3. Whether this is 1 or 8, it needs a 3. So this is a 3. This also needs a 3 on this Ren band because it's 7 in length. 1, 2, 3, 4, 5, 6, 7. Therefore, it requires a 3 somewhere, but it cannot be any of these cells. It cannot be either of these cells, so therefore this must be a 3, which makes this a 6 and makes that a 3. Similarly, this has to have a 3 on this Ren band. It cannot be here, cannot be here. It could be here or it could be here. We don't know, actually. So it's one of those two. We also need a 5 here. This can't be 5 because of that 5. This could be 5, or this could be 5, and this or this could be 5. So we're not sure. We do need a 4, so one of these 3 has to be a 4. Since one of these 3 has to be a 4, because these can't be 4, because of the 2, 4, 2, 4 pair, and this because of the 2, 4, 2, 4 pair, one of these 3 has to be a 4, because you always have a 4 on the Ren band. Therefore, this can't be 4. This has to be a 2 then, which makes that a 4. Oh, we could have already tell from that too. Now, 2 is never along this Ren band. So because 2 can never be on this Ren band, it can never have a 1 with it either. And there can't be a 6 with it on it either because we already have a 6. So this can't be 1 or 6. This has to be 9. Not all of them. This has to be 9, which forces this to be a 5. This can't be 5 or 9, and this can't be 9. So what's remaining here? This can't be 3. Where is the 3 in row 7? It has to be here. So this is a 3. This has to be an 8 or a 9. Well, if it has an 8, either 8 or 9 with it, it cannot be with 1. So therefore, this has to be a 6, which forces this to be 1. Now, we need a 4 somewhere. So this could be 4, or this could be 4. This can't be 2, though. Well, we have an 8, 9, 8, 9 pair in column 7, so 8 and 9 cannot be in the rest of the column. This can't be 6, because we already have a 6 on the Ren band, so this must be 4. Which means this cannot be 4 on the Ren band, so this must be 2, which makes this a 4. Therefore, that makes that 2. This is 2, 4, and then this has to be 8. And this Ren band has to be 2 through 8 too, because we have a 2. So this is 9, this is 8. This has to be 3 through 9 then for this Ren band. We are missing a 4 and we're missing an 8. But this can't be 4 or 8, so this must be a 3, which makes this 4 and 8. Which means we have a 4, 8, 4. This can't be 4. This must be 8, and this must be 4. Which means this has to be 9. This has to be 8. This 8 means this can't be 8, so this is 9, which makes that 8. The last remaining digit in column 3 is a 5, so that's a 5. And this has to be a 3. So the remaining digit now in box 1 is a 6. So this is 6. We're now missing 8 and 9. And now we're just doing Sudoku. This has to be 1. Actually, this isn't quite Sudoku. This is 1. So it has to be 1, 2, 3, 4, 5, and 6. And we're missing 4 and 6 here. So this is 4. This is 6. Actually, that was just Sudoku. This has to be 2. This is 4. This can't be 1, so this must be 1, which makes that a 9. We're missing 1 and 9 here, and 1 and 9 here. This is missing 1 and 6 here, and 1 and 6, but this can't be 6, so this is 1, which makes that a 6, This can no longer be 1, so this is 9, which makes that a 1. And the last remaining digit is a 5 here, and this has to be 9. This can't be 9, so this is 8, which makes that 9. This can't be 5 here, so this is 7, which makes that 5. The last remaining digits are an 8 and a 9 here, and we have a 5 and a 6. So this is 6, and this is a 5. And that's how you solve it. Very cool, like, sort of, yeah, very cool drawing. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.